Factorless expression. So let's do that. I know the only factors of 5m. There is no greatest common factor on this one again. It would be 5m and m. I should always look for that greatest common factor. I keep going back to that. The only factors of 3 are 3 and 1. So if I put 3 and 1 here, that gives me 3 and 5. That's never going to give me a 14. So let's try it the other way around. We're going to put 1 here and 3. That gives me 15m and a 1m. Now some of you are just adding those and saying, well, that doesn't give me 14 either. But remember, we really have to think about adding them or subtracting them, especially when this is a minus. When it's a plus, we're always adding, but when we need a negative sum, we know one has to be positive, one has to be negative. So I need a negative 15 and a positive 1 to get me a negative 14. So I'd have a negative and a positive. The next one, there is no greatest common factor. Put 2x and x. Well, again, the only factors of 3 would be 3 and 1. If I put 3 here and 1 here, this is going to be my best bet because I get 3x and a 2x. That gives me a positive 3 and a negative 1 or negative 2, which gives me a positive 1. Positive and a negative. Next one is a little more difficult because it's got lots of factors of 20. I could very well need to use 20 and 1. I could need to use 2 and 10. But I'm going to try just 4 and 5 first, and I'm going to hope for the best. Factors of 9 are 1 and 9 and 3 and 3. So if I try 9 and 1 first, that gives me 45 and 1, or 45 and 4. That's no good. If I try 1 and 9, that gives me 5 and 36. That actually might be good. 5 and 36, you guys are thinking maybe that's not right, but I notice I need a negative product, so one of these has to be negative. I need a negative 31, so that would make a negative 36 and a positive 5. So positive here and a negative here does give me the correct answer. What I was saying earlier is there is a possibility that you would have had to use a 10m and a 2m to get your positive 20. They would have given you different numbers inside of here, like 6 and 30. That wasn't what we needed, but there is a possibility that you'll have to use other factors than the ones that you do. We're always looking for a greatest common factor. This one has a greatest common factor, and the factor is 2. So we're going to take out a 2 out of each one of these. 2 times x squared is 2x. 2 times 6 is 12. 2 times 5 is 10. Now what I'm going to do is just carry my 2 with me and make sets of parentheses. That does make it way easier. We like it when it doesn't have a number out front. We know it's just x and x. The only factors of 5 are 1 and 5. So I know I have to put 1 and 5 in here somehow. I get 1x and a 5x. Well, I need a negative 6, so that means both of these would be negative. For the next example here, I have a 4m squared. There's different things that will give me 4, but I also need to check for the greatest common factor. 4 doesn't go into 6, but the next factor is 2, and 2 does go into all of those. They're all even numbers, so I can take out a 2. 2 times 2 is 4m squared. 2 times 7 is 14m, and 2 times 6 is 12. Now I'll just carry that down. I'll put 2m and an m. I need factors of 12. That will give me 7, but it's beyond just looking at the factors themselves. We're going to have to put them in, because if you go with your first gut, 3 and 4, you get 3 and 8. That's not giving me 7. So let's try something else. I'm running close to time. I'm going to go ahead and just pick the correct ones, which would be, oh my goodness, I don't even have the right things factored here. Let me back up. I need not 12 here, I need a 3. So that makes it easier. So now I'll put 3 and 1 here. That's 1m and 6m, sorry about that, which does give me my 7m.